A standard chemical equation often appears to new students as a chaotic, confusing jumble of letters, subscripts, and coefficients. We are going to organize that chaos by building a reaction mastery study guide together. This guide provides the exact steps needed to classify reactions in seconds and balance equations accurately. Chemistry relies on a predictable system of pattern recognition. Step 1 is identifying the 6 structural patterns. In a synthesis reaction, 2 simple elements merge into one compound. Decomposition is the reverse. A single compound breaks down into separate elements. Single replacement occurs when a reactive element replaces a specific part of an existing compound. A double replacement reaction involves an exchange of ions, where 2 paired compounds swap partners to form 2 new products. Neutralization is a specific type of double replacement, where an acid and a base react to produce a salt and water. Combustion reactions are defined by a hydrocarbon reacting with oxygen to produce carbon dioxide and water. Identifying these basic A, B, and C block arrangements allows you to recognize the structure of most chemical equations you encounter. These abstract formulas describe the physical changes happening around you every day, from cooking to cleaning. When an iron pan rusts, you are observing a synthesis reaction, as iron binds with oxygen from the atmosphere. Mixing milk with lemon juice produces a curdled precipitate, which is a visible result of a double replacement reaction. The bright blue flame that you see igniting on a typical gas stove represents an exothermic combustion reaction. Recognizing these formulas helps you identify the specific molecular changes occurring in the objects around you. To classify any equation, use a diagnostic checklist. Focus your attention exclusively on the reactants, the substances on the left side of the arrow. One reactant indicates decomposition. 2 separate, simple elements indicate synthesis. An element reacting with a compound signals single replacement. 2 compounds reacting together signal double replacement. Then this checklist turns classification into a simple process of elimination. Once you classify the reaction, you must balance it. The law of conservation of mass states that the number of atoms for each element must be identical on both sides of the equation. We will use the combustion of methane, CH4 plus O2, to demonstrate the balancing steps. Faster, if a polyatomic group like OH appears on both sides of the equation, count it as one intact unit on your chart. Use the hit and trial method. Adjust the external coefficients in front of the boxes until the atom counts on both sides match. This process serves as an accounting check to verify that mass remains constant throughout the reaction. We have now completed the Reaction Mastery Guide, combining the 6 structural patterns, the reactant checklist, and the T-chart balancing method. Let's apply the guide to a final equation: aluminum reacting with lead-2 nitrate. The presence of a lone element and a compound on the reactant side identifies this as single replacement. From there, the T-chart allows you to find the exact coefficients needed to balance the mass. Take a screenshot of this guide to use as a permanent reference for your coursework. By following these structural rules, you have turned chemistry into a logical, predictable system.